Hello, everyone, and welcome to your next talk of the day. It is my pleasure to introduce our next speaker, Chetan Jadhav, and he is the Director and Analyst at UBS Financial Services. And his talk today is entitled Computer Vision-Based Robotic Process Automation. So please welcome to our virtual stage, Chetan. Okay, you can join us. Hello.
Hello, thank you, Morgan. Really appreciate this opportunity to be the part of AI for conference this year. Today, I will be talking about the topic. Let me share my presentation. Okay, so today I will be talking about computer vision-based robotic process automation. I will briefly talk about the technology, the industry, the challenges faced by the industry, and then I'll talk about computer vision as a potential solution for some of these challenges. So before taking a deep dive into the actual RPA, let's first talk about a typical business process workflow. So this was I created like a simple example of like online ordering system where a customer puts an order online here. This order then get checked by some employee if it is valid or not. If it is not valid, it is rejected. If it is valid order, then it is further processed. The item is checked. If it is in the stock, its order is further processed. If it is not, then it is the order is put to vendor, and then it goes through whole warehousing process, and finally when the order is there, the order is shipped, payment processed, and then finally your online customer gets the order. So this kind of workflows are everywhere. These are simple workflows. Every industry has this, like e-commerce, financial industry, medical industry, insurance industry. I come from financial industry, and I come across this kind of workflows everywhere. And that's how my exposure to RPA is because of this kind of workflow automations. But when humans perform this kind of automation, I use this analogy of hiring the great artist DaVinci for painting your walls. It's a simplistic task, like when we hire humans to do such a simple, monotonous, boring task. It is, first of all, very expensive for the firm because they are hiring human employees. Second thing, it is not necessarily fast enough. Humans are not as fast as computers. And lastly, it is very error prone because due to fatigue, the error rate in humans can increase due to fatigue and monotony. Not only that, this particular, I came across this research, this long-term, the effect of long-term exposure to low complexity work were studied by these researchers, and they found that this long-term exposure to low complexity work can have detrimental effect on brain health markers. I'm using a cartoon of Simpson. It shouldn't be considered as a insensitive. I know it's a very sensitive subject nowadays, automation and taking over the job, but it doesn't need to be that way. I mean, if you go back to our earlier example of this workflow, there are several opportunities for humans to use their brain. For example, if the order is not available, item is not available, they can reach out to customer to provide an alternative, increasing the sales of the firm. They can do better negotiation with the vendor. So there are several opportunities where humans can work together with machines and adding value or adding to the bottom line of your enterprise. So my view on this is that this humans can work together with machines, which can be beneficial to humans as well as the firm. So how do we automate this kind of workflow, which is fast, cheap, accurate, and healthy to employees as well? So the first approach, which is called like API-based automation, which is the first choice. The API, the application program interface, is specifically designed for machines to talk to machines. It is quite robust the compared to other approaches, and lastly, it is very cheap. But the most important point here I would like to note is it's not always available. There are several reasons. Like, for example, the legacy systems may not have the API provided at all. Even the systems are new, the vendor or the application provider chose not to provide API functionality at all for several reasons. So that's why, even though if it is it's a cheap, fast, robust option, it's not always available. And that's where the RPA or robotic process automation comes into play, where it acts the RPA, which is nothing but another software, acts as an intermediary between different GUIs, extract information from one GUI, put it to another GUI, using GUI as a means of communication or linking the communication between different applications. The problem with the RPA-based approach right now is this is implemented using specialty tools, the RPA tools, which is not necessarily cheap at the moment. At the same time, there are maintenance costs of these processes, as well as the licensing fees, maintenance licensing fees for these tools. And lastly, which is where I will talk about, is that there are several situations where this option may not be even available, and that's where computer vision comes into play. So what sort of task RPA can automate? Basically, any GUI-based task. Like, if we can work with GUI, RPA or RPA bot can also work with that GUI potentially. It can transfer information from one application to another application. I will show one video on how this thing works. Pretty much anything which you can do on a computer using eyes and hands can be done, of course, without brain. That's the whole point. RPAs, I specifically showed that no brain required, because these processes are simple process where not a whole lot of brain power is required. And also, lastly, these are softwares. These are not physical machines, so they can't bring you coffee yet. So we are not there yet. So this is an example which I found it on KPMG. It's a YouTube site. It's a pretty good example on, like, it shows like how RPA works. I will use this to motivate the entire process. So at the beginning of the process, the software robot. Towards the right of the screen, we have this RPA tool where the RPA workflow is implemented using this flowchart-like diagram. The typical implementation of RPA is not using writing code, but like drag and drop of this flowcharts. And this is how it's implemented. And towards the left side, you will see different applications being opened and data transferred from one to another. Opens the correct environment in SAP and logs in. An invoice request is received by the software robot via email. The robot opens the email and the attached Excel template and scans this thoroughly. Different checks are performed by the robot to determine whether the data from the Excel template is of a certain quality. The software robot runs the transaction code, the creation of invoices in SAP. Subsequently, the invoice data from the Excel template is copied and pasted into the relevant fields in SAP. The robot recognizes if essential information is missing in the invoice request. If this is the case, the robot sends an email to the invoice requester with a request to adjust specific invoice data. When all the data is entered in SAP, the robot creates the invoice by running the correct transaction. So that's like a real example of like how RPA would work, like as would any human would uh, interact with different applications, SAP, Excel, PDF. That's how this RPA process works. So about the industry itself, it is the fastest growing segment, enterprise software segment, as per Gartner's 63% growth they observed in 2018. In 2017, Deloitte carried out a survey of like 400 large enterprises. These are some stats from that survey. 53% of the respondent has already started their RPA implementations. Near universal adaptation expected in next 5 years. 20% full-time equivalent capacity provided by robots, meaning 20% of their workforce, human workforce capacity. Improved compliance, quality assurance, productivity, cost reduction like dimensions. And lastly, this is what I kind of caught my attention, is that only 3% of them are like have scaled their implementation. And that's where like I think might be the issue, is the robustness of this system. The these are the big players in the market. Right now, the market is like a very nascent market. It's just 2 billion, which is expected to be 25 billion by 2017, as estimated by this research firm, Grandview Research. Uh, I have briefly worked with one of these tools. We try to implement with one of our application, but it did not work um, because it could not recognize the elements on our user interface. So now I will talk about like how exactly it works. Like I'll start getting into the technology details of uh, this automation. So mainly it relies on objects handle provided by operating system to various UI element. For example, here if you guys have used with this tool called Microsoft Spy++, it shows like different threads and different window handles available on your computer. Like for example, this is the thread and thread ID for PowerPoint, and within that, this is the handle to the window of my current presentation. So this information is typically used by RPAs to automate, interact with different elements on the user interfaces. This is a big list of like I think 14 or 15 different technologies which produces user interfaces, and this list I got it from UI Path's website. So these are the different technologies UiPath tools can talk to. It's a big list. I mean, I put this entire thing over here to motivate the fact like how complex these tools are. They have to make sure these tools can talk to so many different technologies, even though you might be using just one or two technologies. So that's why it makes this two tools very complex and expensive. And lastly, once you have access to this elements, UI elements, software handle, and you can interact with, then it's just a matter of implementing your logic, workflow logic, as any human would carry out that workflow. So just to give a visual appeal to whole entire process. So here I have broken down your application logic separately from GUI. So the logic talks to your GUI and communicate that information to our eyes. The brain then processes that information and determines what next action to carry out, and then hand implements the next action using the keyboard on the user interfaces. So RPA just replaces your eyes, brain, and hands with the GUI element handle. For example, notice that I'm using the same clip art for RPA logic as well as application logic to motivate the fact this is nothing but just another application. So this RPA logic application gets information from the UI handle, determine what action to carry out next, and implements those actions using a UI handle on the GUI. Pretty much any human would do. The issue with this kind of approach is that this handle to a particular UI may not be always available, and that is where I ran into my issue when I tried to use one of these tools. Second issue is the feedback from GUI is not always available. For example, when we load a web application, we wait for that application to load before carrying out your next action. Yeah, some UIs provide that information where it tells RPA that okay, it's ready for the next application, next action, and that information can be used to carry out next action. But if that information is not available, then typically how it is implemented is like wait 10 seconds, wait 20 seconds, and then implement next action. So that can serve as like a bottleneck and source of being fragile, and it can break it down many times. So that is another issue with this kind of approach. So what I always thought, like why not use computer vision, which is like the same technology used by autonomous driving Google car or Tesla cars to automate this simple task of working with user interfaces. In that process, instead of user handles, we can just look at we meaning the RPA logic can just look at what's on the screen, decipher information out of that screen. The screen is just like a matrix or array of like bits, whereas there is no information. So the computer vision is capable of identifying the different components on that screen picture, screenshot, and then use that information to implement your next action. So that's what I was always thinking, why not implement RPAs this way? I am seeing now when I checked like some of the features of newer RPAs, I do notice that they are implementing some of the features of computer vision, but at the same time, it mainly relies on user interface element software handle. So what I feel is that with this kind of implementation, there are the computer vision can provide like universal access to any UI. It can interact with any complex UI. It is capable of using the feedback from the UI in any scenario. It's very cheap, very meaning like comparatively cheap, because we don't have to deal with 15 to 20 different technologies. And since we are not dealing with so many technologies, you can build RPA from scratch without the need of a traditional tool. That's what I will demonstrate next on my demo. And then once you have access to the picture of the or a screenshot, you can implement several cool techniques such as deep learning for the downstream processing of that information from the screen, and well suited for cognitive RPA, where cognitive RPA is the RPA which teaches itself. So this is a proof of concept which I built. The idea is many firms interact with their client using LinkedIn, but they also want that information back in there. They may also want that information back into their CRM. What if LinkedIn does not provide access, backend access, so that CRM can tap into that and get that conversation information back into their CRM. So to handle such kind of situation, this proof of concept shows that computer vision can be a very good candidate to handle this kind of automation scenario. This whole actions are performed by bot, uh, and nothing is manual. The red box do appear in between, that shows that what area of the screen the bot has identified, just as a demonstration purpose. So here you see that, like, I mean, the bot has entered the email address and password to log into my LinkedIn web page. Then the bot goes into identifies the top bar where the messaging section button is there. Again, that's based upon visually how the button looks like. Then it presses that button, it identifies the message area of the screen, and the sender information area on the screen. I have grayed out this area because to respect the privacy of my professional contacts who have sent like different messages. I don't want, I don't have the permission of each and every message sender, so that's why I've graded it out. But this is how it should look like. So once you will see that it is going one after another message, scrolling the whole area of the message, and then once all the available senders are exhausted from the view, it will scroll for the next set of senders. So while it is scrolling the message, it is using the technique of panoramic pictures when we take using your cell phone, where the cell phone takes multiple pictures and stitches it into a panorama. So this RPA in this case scrolls through the message area, stitches different parts of the message area, put it together, and creates a big vertical message pictures, which later on then recognized using optical character recognition to convert the picture information into the
Right,
text.
you have just under a minute left, just so you know.
Okay, I am almost done. So the feature, so the different techniques used in this kind of this particular proof of concept is feature detection and extraction, optical character recognition, and feature-based panoramic image stitching. So in summary, RPA is fastest growing enterprise software category. There are still some hurdles in universal adaptation, and computer-based or computer vision can be a potential solution for its universal adaptation. So I do have a slide. If anybody has question, thank you. Thank you, Morgan. Back to you.
Great, that was an awesome talk. If you could unshare your screen, please, and your camera. And I hope you all enjoyed. I thought that was really great, and stick around and enjoy your next session. Thank you.